Hey folks, welcome back to another episode of Advent of Code in F#. We're day 3 already, and believe me, this is also take 3 already. I had a lot of technical difficulties, some hardware issues with the mic, which made my first 2 takes unusable. So here we are again. But without further ado, let's take a look at what we did today and how you could go about solving this puzzle in F#. Day 3 is Mull It Over, where we are given a piece of corrupted memory and there's some instructions in there. We needed to find all the mull instructions and execute them. That's basically it. So let's take a look at how I tackled the problem. Starting with part 1, of course. So I used, like most people will have, probably, I used regular expressions, regexes. And I have a lot of trouble myself when I work with regexes. I'm not the king of regex, but there's a very helpful site called regex101.com. There are probably others, but that's the one I know and use. If you type in a regular expression and you type some examples below, this site is very good at explaining what's actually going on. So for example, to the right here, it's saying like, okay, this is a capturing group. When you put something in between parentheses, this /d means this and a plus means this. So it's really good at explaining what's happening and how things get captured. So if you're working with regexes and you need some feedback, you can use this website. I use it all the time. So I parse using regexes, and I just parse into tuples containing the left and the right operand for this mull instruction, and then I just run over the list, multiply everything, and sum it up just fine, and that gives us the result. So that's not too hard once you struggled through the regex part. Part 2 actually got quite more interesting. Part 2 introduces 2 extra instructions. So instead of 1, we have 3 instructions. It's a do and a don't instruction, and they just enable, disable multiplication mode. So if we encounter a do, from then on, we have to do the multiplications. But if we encounter a don't, we don't do any multiplications until we see another do. So we can't just map over the list. We need to keep track of some state while we go through the list. So map, list.map won't work very nicely. And I just grabbed for the power tools. I didn't know an alternative, so I grabbed for the function called List.fold. And that's one that takes a bit of getting used to if you haven't seen a fold, but it's not too tricky once you've seen it work a couple of times. Let's take a quick look at this function signature, right? So List.fold takes 3 arguments. It takes the list of t, which is our list of numbers. And it takes a folder function, and that itself is a bit tricky, and it takes an initial state. My initial state you can see here to the right. It's a type I declared myself, result type, and it keeps track of is the feature toggle enabled or disabled, and it keeps track of the running total up until now. Initially, the initial state is, yes, we are doing multiplications, and our running total is 0. Okay, now down to the folder. Folder takes intermediate state, like it is this structure like here. So it takes the current intermediate state and it takes the current element of the list. And with those 2 things, you can figure out like, okay, what's the next version of the state? And that folder function should return an updated version of the state. And then it loops through every element in the list. And at the end, you get like the final state that has been calculated back. And that's how I use this thing. Before I dive into the folder instruction, let's take a quick look at our parser, because that has also been growing for part 2, and I didn't really explain how I did it. I just used the or the pipe thing in regular expression. So this regex matches on one of 3 options, the original mull or the new do or don't instruction. And I think today is also the first time I used pattern matching, which you see here, and where this thing, my instruction is like it's a union type. It's something like an enum, but it's an enum on steroids because you can attach data to each and every case. This pattern match thing is like an if statement on steroids because you can do a lot of powerful things with it. But we are not using anything fancy. We're just matching on the regex matches. And if it's a do match, we just return the do case. If it's a don't, we return the don't case. And otherwise we know it's the third alternative, the mul right here. So we just parse out the left and right operands and parse that into a mul instruction. Why? Why am I going from these strings to this union type? Well, that's because my folder now is a bit more clean. I don't see any strings here. I just see these types I introduced. And that's handy because if you have a union type instead of a string and you pattern match, the compiler can check for exhaustiveness. So if you forget a case and you're working on a union type, the compiler is very helpful and says like, oh, you forgot a case. You don't have the don't case in there. If you keep strings, if you just keep working with strings, compiler cannot help you. There's a lot of different strings that could be pattern matched upon. So that's why I prefer working with union types myself once I parse into alternatives or something like that. But anyway, let's take a quick peek at the folder function. That's the last piece of today's puzzle. Folder, as I said, takes intermediate state and the current element of list, and you have to figure out the next version of the state. Or I called it result here, but that's the state thing we're talking about. So I just take a look at the current instruction. If it's a do, I enabled mul mode. I do that by putting this enabled flag to true. If it's a don't, I disable mul mode. This with keyword, if you're familiar with C# records, those are like the data structures that are immutable by default, and you can just create efficient copies with the with keyword. That's exactly what's happening here. So result is a record type. Result is not being changed here. We're just creating a new copy, and it's an efficient memory copy, so it does not copy the whole object. It copies like the things that change, or it creates a new version. So it's what I'm trying to say. It's pretty memory efficient. It's not something to be scared of for all you performance knuckleheads out there. It's slower than like handwritten C or Rust, but it'll get us there. Anyway, so yeah, I update the state with like the feature toggle here. And in the third case, I take a look at the feature toggle. If we are running in mul mode, then we do the actual multiplication and we add that to the running total. That's what's happening here. And if we are not in mul mode, if the feature toggle is disabled, we just ignore this current mul instruction. We don't have to do anything. We can keep the result as is. And that's how we got through day 3 of Advent of Code in F#. This was a really fun puzzle again. I had a lot of fun. I hope this was the last of the technical difficulties. But let's figure out tomorrow. I hope to see you again then. Bye bye.